All right, so this is going to be Geometry Lesson 2-6. This is a little bit different because I have a substitute today, so I'm including the warm-up in the video. So those of you tuning into the video that are students, go ahead and copy down this warm-up. There's 2 problems. I know it's a lot of writing, but you need to copy all of it down. Copy down all the different choices that you're allowed to choose. You might be able to, I don't know, condense the problem. Maybe you want to say 500,000 into 600,000% increase question mark or something like that. So do that, pause me, and I'll start talking when I'm unpaused. All right, so you have unpaused me now, and I want to go ahead and talk about this problem. So percent increase is always the same formula over and over again. So here it is. Percent increase. This is equal to new minus old divided by old. Over and over again. This is the same formula for both of these equations. So new is going to be our 600,000. So this is going to be 600,000 minus our old 500,000. 500,000. All of this divided by our old of 500,000. 500,000. All right, so the numerator here becomes 100,000 divided by 500,000. Handwriting is getting a little bit bad because I'm going fast. All right, and we basically have our answer. We just need to make it into a reduced fraction in order to turn it into a percent. So reduce this fraction, I'm going to divide the top and bottom by 100,000, and this reduces into 1/5. If you know what 1/5 is now, hooray, you know what the right answer is. And in order to reduce this, or to turn this fraction into a percent, the best way of doing this is to memorize it. But I guess the next best way is to multiply the top and bottom by 2/10. And whenever I divide by 10, I move the decimal place 1 back. So this is equal to, it used to be 2, and then I move it 0.2. And 0.2 as a percent moves the decimal place 2 to the right. So it used to be 0.2, moved it 1, 2, and percent, 20%. Correct answer is B. All right, and finally, this next one is going to be same process, same formula. It's going to be new minus old divided by old. So new is 17. The old is 20. This is going to be divided by old, 20. All right, so this is going to be a negative number. That's fine because it's a percent decrease, so that makes sense. So it's a -3 over 20. Now turn him into a percent. How do we do that? I'm going to do something a little bit tricky here. I'm going to go ahead and try to get a 10 in the denominator. Then I can use this 10 rule where I just move the decimal. But it means I'm going to have a decimal in the numerator, but I think that's fine. Or I could, I think a better way of doing that would actually be to multiply the top and bottom by 5 to get it percent per 100. So times 5 times 5, that's going to be a -15 over 100. This literally means -15 per 100, -15%. This is -15%. That's how to read it. A little shortcut there, I like that. So B and B, both correct answers. All right, I'm moving on to the actual lesson now. So we are on lesson 2-6. Go ahead and write your line for your Cornell notes. We're on standard E. What is standard E? Go ahead and take a look at your, oh wait, we don't have unit guides for this class. Never mind. Standard E, that is in our syllabus, triangle properties still. We already talked about triangle inequality theorem briefly for like half the day. Today is our full day to make sure we really understand what's going on. So this is the official definition of the theorem. So go ahead and pause me, write all this down, and let me talk. All right, so you've unpaused me. So the sum of lengths of any 2 sides of a triangle is greater than the length of the third side. So I want to turn that into an inequality. In fact, I want to turn it into 3 inequalities, all the different possibilities. So if I'm looking at our triangle ABC, that means I'm just going to choose some random side lengths. So maybe instead of labeling this A, B, and C, I should have labeled this. I'm going to do lowercase a. Maybe I'm just going to do numbers. That'll confuse us. 1, 2, and 3. So I'm going to say that 1 plus 2, that has to be greater than 3. I'm literally reading this verbatim. So the sum of lengths of any 2 sides, I chose 1 and 2, those random 2 sides. You could have chosen any 2. Those have to be greater than, there's my greater than symbol, the length of the third side. So there's my third side with a circle. But what if I chose a different number? What if I chose 1 and 3, 1 plus 3? That needs to be greater than the remaining side of 2. And our final inequality that you need to memorize, and I guess once you memorize this statement, you're really good on all the inequalities, is 2 plus 3. Those are the last two sides that we haven't chosen. 2 plus 3. That needs to be greater than the remaining side of 1. If all three of these are met, then it is a triangle. So that's the official triangle inequality theorem. Let's go ahead and do an example now. So moving to the next slide. So this is going to be an example. I'll change it blue here. Example. So let's just, I think we're going to do a few examples. So we'll label them example number 1. Can this be a triangle? What I'm asking you to do here is apply the triangle inequality theorem and see if this is true. So these lengths are going to be side lengths. So I'm going to choose 9, 13, and 21. Can that be a triangle? I don't know. So there is a shortcut. I'm just going to go ahead and do it the long way first. So triangle inequality theorem, I'm going through all three possibilities. So let's check all three possibilities. Let's choose 9 and 13 first. So I'm going to do this in a different color, showing you that I'm working on this problem. The problem was in blue. Black is the problem solving. 9 plus 13 needs to, oh, that's 3. 9 plus 13 needs to be greater than 21. And I'll check that off if it's true. And then I need to set up all the rest. 9 plus 21 needs to be greater than 13. I mean, that's obviously true, right? 21 just by itself is bigger than 13. And then finally, I need to do the last one, which is 13 plus 21 needs to be bigger than 9, which is pretty dumb because I have 21 and 13, which are both bigger than 9. Obviously, the sum is bigger. So I can go ahead and say, yes, yes, you are true. Yes, you are true. Check this one. 9 plus 13, that's going to be 21. Oh, sorry, that's not 21. That's 22. 22 is bigger than 21. That does work. So have you found the shortcut already? The shortcut is just to choose the two smallest ones. So we'll write that over here. Shortcut. Shortcut. Just check smallest two values. All right. But the triangle inequality theorem can be applied to slightly different problems that we haven't seen. I mean, we might have seen them in the notes before, but I'm going to make them more explicit this time. I need to ask you a range of values that the triangle can be. So coming back to our problem up here, these equations, they can actually be turned into different equations. So say I had, and I know I'm kind of going back and adding on the notes, I can make this a subtract sign. I could have said 1 needs to be greater than 3 subtract 2. I'm just subtracting 2 from both sides. So that's where the other part of our notes came in, where you can have subtraction. All right, so what I want to do is ask our final example, and then we can work on the homework. It's kind of a short lesson today. So number 2, if a triangle, I'm just going to abbreviate here, if a triangle has lengths, GT, okay, I can spell here, lengths 21 and 19, what is the range, kind of important here, range of values the last side length can have? Side length can have. Okay, so this one you can still apply the same theorem, but we don't know what that remaining length is. In fact, we should maybe call it a variable. Let's say the remaining length, we can say remaining length I'll just call him x, just like we call everything else x, right? So apply the inequality theorem. So what is that going to mean? That means that if I have, just choose two random ones, so I'm going to say 21 plus 19 needs to be greater than the remaining x. And all three possibilities need to happen. So if I choose 21 plus x, that needs to be greater than 19. And finally, 19 plus x needs to be greater than 21. So what is the range of values? So I have to kind of solve for all of these. So in this case, I'm going to change to black here. In this case, this turns into 21 plus 19 becomes 40 is greater than x, or vice versa. You can say x is less than 40. All right, and then from this inequality, I have x on this side. I'm going to subtract 21 on both sides. So I'm going to say that x needs to be greater than -2. So I subtract 21 greater than -2. All right, that looks good. And finally, over here, if I subtract 19 on both sides, then I'm going to say that x has to be greater than 2. I'm going to switch this one around a little bit just to make it more consistent. So this one turns into x is greater than, sorry, that's not right. X is less than 40. All right, so all of these conditions apply at the same time, so you have to be very strict. Because if I choose, say 0, 0 is bigger than -2 for x, but 0 is not bigger than 2. So I have to be the strict as possible, so I don't really care about this one. That one's too low. I care about the most strict, which is 2. So the answer here is between 2 and I think we remember how to do a compound inequality. I'll just go ahead and do a compound inequality here. X needs to be greater than 2, and it needs to be less than 40. And if you don't like a compound inequality, you could just use interval notation. Say for x, it has to be between 2 and 40. And that just comes from doing a bunch of inequalities, 3 of them to be exact, and figuring out which one is the most stringent. 2 of them should cancel out, and one of them should twist around like this, so it's a less than when you're doing these problems. All right, so that's all I have for the notes. Go ahead and write your summaries and ask for the worksheet after you have your summaries complete.